So it looks like we're back now. Hopefully the title has updated. It does look like it has updated. So we'll just give it a few minutes and then we'll kick off with this brand new 2019 knowledge transfer session. Thanks for tuning in, those that have tuned in today. I appreciate your time. Hopefully you'll be finding this session very useful, whether that be for something that you're doing to do with IBNS 2.0 today, or maybe in the future this may be relevant and useful for yourself. Hey Tiffany, thanks for tuning in. What's good? It's been a while. Ali, I'm good. How are you? Thanks for tuning in. Thanks for rocking me today. Back on the live stream today. And Hamid, hey, what's good? Thanks for tuning in, guys. Hopefully you will stay with me throughout this session. And if you got any questions, feel free to reach out, and I'll do my best to answer it. So what we'll do is we'll kick off this live stream now. For those that are not watching live, you obviously can rewind and fast forward to the specific spots that you want. For those that are tuned in live, again, thanks for tuning in. Just before I kick off, I just want to give Dean McKenzie a big shout out. Dean McKenzie is very active, currently studying for his CCIE routing and switching, and towards the back end of last year he donated to my GoFundMe page to help with the assistant server, which will enable me to deliver more advanced labs. So big shout out to him, and also big shout out to yes sir. I didn't get his real name, but he also sent in a donation as well, so big shout out to those guys. The donation page is still live. It's scrolling across the bottom of the screen now, and I've got quite some way to go actually before I actually reach my target in order to get the parts to actually build the server. But hopefully, that should be coming at some point this year as well. So big shout out to those guys. So here we are, 2019. This is my first knowledge transfer session of 2019. For those who tuned in last year, I brought you guys I think 10 different episodes of different topics that I wanted to share with you guys, and also topics that you guys had actually requested that I deliver on. So I got some good feedback on that, and everybody seemed to like that. So I've decided to go again with season 2, and this is episode 1. So again, this is going to be focusing on IBNS 2.0. For those that are not aware of what that is, don't worry, we're going to talk very briefly about that. And as I say, it might not be relevant to you now, but if you're certainly going down the security track and you work with Cisco products, Cisco switches, Cisco ICE, then this may become useful to you at some point in the future. So getting into it then, so I've put some assumptions here, but don't kind of take these, just kind of take them with a pinch of salt, and it's just basically saying that to better understand what we're going to talk about today, you'll have a basic knowledge or a basic understanding of secure access control using ICE. You'll also understand or have a basic understanding of what IBNS is, so identity-based networking services, and that's what we're going to talk about mainly today. You'll also have a basic knowledge of AAA configurations, and the basic knowledge of C3PL, or in other words, Cisco Common Classification Policy Language, which is a bit of a mouthful. But again, take that with a pinch of salt. I'll do my best to describe these and explain these, and if there's any questions on the way, feel free to stop, and I'll try and answer you. I'll try and answer your questions. So I've put some useful links, two useful links actually. So one is an overview of IBNS 2.0. So this is so you can kind of get a little bit of a better understanding about IBNS 2.0, because this knowledge transfer isn't going to explain it in depth. That's not the purpose of that. The purpose of this this knowledge transfer session today is actually to show you the configurations and show you how it can be configured to secure access to hosts or devices that require network access. I also, for those that I haven't seen yet, I did a post, a new post today on my website, and that's called Demystifying IBNS 2.0. It's quite an in-depth post, and again, this aims to kind of break down the policy and show you kind of how it all fits together. So I've took part of what I did from the article today, and I've put it in this session today, so hopefully I'll be able to elaborate on that a little bit more as well. But they're the two links. Within my link as well to my website, I've actually got other links to Cisco websites mainly, that or all Cisco websites that actually explain IBNS 2.0 and its configuration as well, so check that out. So just before I get into the overview, let me just quickly see if we have any questions. So Ali, I see you got an exam coming up. What exam is that? If you let me know what exam that is. And good luck, I'm sure with the right resources and the right studying, you'll be able to smash that exam. Cash, thanks for tuning in. Welcome. Sounds like ITIL. Not quite. I mean, ITIL, if we're talking about the same thing, is obviously a project management thing, whereas this is more related to the actual configuration of switches, Cisco switches. Okay, so let's jump in. So a quick overview of IBNS 2.0. So it's also known as identity-based networking services. It's been around for some time now, and the traditional way of actually configuring identity-based networking services is generally done using IBNS 1.0. So IBNS 2.0 is a newer way of actually doing identity-based networking services. So as it says there, it secures the access layer for devices that are required to authenticate onto the network. So essentially, if, for instance, you have a PC plugged into a switch port, what that's going to do with identity-based networking services is actually lock down or restrict that switch port until you've actually authenticated onto a network with credentials that are valid, whether that be certificate authentication or username and password using Active Directory or LDAP, stuff like that, or even MAC authentication bypass, which is using the MAC address to authenticate to the network. So that's essentially what it is, and it offers a more flexible way of working with IBNS. And the reason it does, or the way that it does this, is by using something called Cisco Common Classification Policy Language, or C3PL. And it's also a more dynamic way, and the reason it's flexible and dynamic is because the old way of actually doing identity-based networking services or using IBNS 1.0, it was it was more of a static configuration whereby you would configure all your global configuration, and then for every single switch port that you wanted to secure, you would have to configure the same configurations on every single switch port. So you'd end up with hundreds of lines, and it's not really good for the switch, and it's not scalable. So the way that IBNS 2.0 does this, and we'll see this a little later on in the configuration, is we actually configure C3PL. So C3PL works on, for those that have done your CCNA routing and switching, or CCNP routing and switching rather, C3PL works on class maps, policy maps, and service policies, to actually build up a policy, a dynamic policy for devices that require access to the network. And all we have to do, instead of actually applying loads of different configuration to each individual switch port, we just apply the policy or different policies to a switch port, and then the actual policy, depending on the order and depending on what's in the policy, is evaluated to actually give or provide that network access. So again, it sounds like a lot, but and I mean the configuration actually looks like a lot when we take a look at that shortly, but rest assured, once you get your head around the C3PL, it's actually not that bad, and that's what I aim to do today. I want to try and explain it so that you can actually understand it and not look at it and think it's really scary or off-putting. So as I say, it's easier to manage. It makes managing a switch a lot easier by applying policies rather than the same configuration to multiple switch ports. Okay, excuse me. So I've put together a little lab topology today, and this is essentially what it looks like. So this is actually my lab environment here. I have a physical lab just down here. I've got an IP phone here, which is also in the topology today, so we'll be able to have a look at some, the phone authenticating. And I also have a laptop we'll be able to take a look at as well with the configuration. So this is the topology. So they're the N2OS that I just talked about. We have the access switch. So the access switch is where you configure the identity-based networking services configuration. So essentially any switch where you have endpoints connecting to and you want to secure the access, then that's where the identity-based networking services need to be configured. I have a distribution switch which is acting a little bit like a collapsed core. There's also other elements within the lab environment, but the other relevant piece connected to the distribution switch is the iServer. So this is a standalone physical appliance which is down here. It's based on a UCS C series. So that's a physical thing sat here. I'm not too sure if you can hear it on the audio. So all this is physical. So you get the joys of actually looking at physical things today. Let me just stop and see if there's any questions. CCNA routing switching. Nice, the nice foundation step. Well, hopefully you've done enough studying to actually pass that. I'm sure you've been looking at resources online in terms of ways to pass the exam, whether that's been watching Dewan's videos. So shout out to Dewan. We need to have a catch up, by the way. We need to get on our live session as well. Shout out to Antonio as well. For those that don't know, he went under the knife earlier, a couple of weeks ago, to have some heart surgery. So we're praying that Antonio's on the mend and starting to feel good now. Shout out to Erica as well, also works at Cisco with me, someone that I really look up to, and always there when you need her, so big shout out to Erica. Ali's got a question: is IBNS part of CCNA security or CCNP routing and switching? To be quite honest, the CCNA security is still the same version as when I did it. I think I did it when the version that it's on now was rather new. And there's no IBNS configurations in there. There is no IBNS configuration in the CCNP routing and switching. There is reference to class maps, policy maps, and service policies, so the common classification, Cisco common classification, policy language, bit of a tongue twister. And I'm also working on the CCNP security at the moment. I've done the ICE exam. I'm sure that might be due for an update, but there's definitely no IBNS 2.0 configuration in that either. So I think in terms of certifications, I've not seen it in the I've not come across it in the blueprint for the CCIE security either. So I think in terms of certifications, this is actually something that you have to do on the side, or you either work with it and get to understand it. So that's kind of one of the reasons as well why I wanted to deliver this session, to kind of break it down and kind of understand it a little bit more as well. Okay, so I'll crack on now and I'll answer some more questions after. So just before we jump into the lab, let's just go through the steps on configurations. And I actually want to show you the configuration because there's quite a lot of configuration. So I kind of pre-prepped it so that this session wouldn't take all day or a good couple of hours. And it's easier to actually copy or write the configuration out first, because there's quite a lot and you don't want to get muddled up. So the steps in configuration. So the first point I've put as optional, which is convert the existing IBNS 1.0 configuration. Now I can't do this because I've already changed my my switch to use a new style of the configuration. But essentially what you can do to kind of keep it short is you can do the configuration the traditional way, by configuring the global settings and then configuring the port level configurations, and then you can actually convert to the IBNS 2.0 config, and the switch will automatically convert IBNS 1.0 configuration to IBNS 2.0 configuration. Now it sounds like a lot. I'm not going to really touch on it today because like I say, my physical switch has already been converted to the new configuration. But if I just kind of quickly show you on my blog post. I'll just get that up for you. So on the post that I've done today, and we're going to look at a little bit more of the policy in a minute, I've broke it down and I've put in the consideration section. I'm not sure how good that is in terms of visibility. Let me just zoom in there. So in the consideration section, I've kind of put there that it's often easier to implement the required global configurations, as I mentioned, as well as the interface level configurations using the IBNS 1.0, and basically explained that the configurations automatically converted once you enter this command, which is authentication display new style. I've also put another consideration, which is when transitioning to IBNS 2.0, you should remember that you won't be able to transition back to the old style of IBNS if you've made any change to the control policy, or you've issued a copy run start. Hence the reason I can't go back and show you that transition unless I get another switch now. So I'm kind of stuck with IBNS 2.0, but that's fine. And just another observation, we spoke about C3PL. So within IBNS 2.0, it's slightly different. So class maps are called control policies. You might see reference to control policies. That's class map. Control class, sorry. The control policy is a policy map, and the control service policy is the service policy. So that's just a few things to kind of bear in mind. So if we decide not to use the conversion, or if we decide not to actually convert, then we actually need to transition to the new style by still issuing the same command, and then we need to configure control classes from scratch. Now when you convert to from 1.0 to 2.0, the control classes are automatically configured. To be quite honest, I've not converted without having any configuration and seeing if it automatically configures it again. So but my assumption is that it doesn't do that. So you've got to configure the control classes, then you configure the service template. So that's something that I've not mentioned yet. So a service template is simply put, it's like a policy where you can specify a VLAN or an access list, or I think quality of service, things like that. Again, we'll look into this later on. We then need to configure control policy, which is the one of the main parts of it, and then we need to configure the service policy. So this the configuration of the service policy is simply going on to the interfaces that need to be secured and applying the control policy. And then last but not least, we need to test and verify the configuration. So this is obviously something that you'd be expected to do in a production environment. So what I've decided to do today is we will go through the actual configuration steps, and we will test and verify configurations. So onto the actual policy, we have what you're looking at on screen is the actual policy. Just bear with me a minute. Okay, so what you're looking at there on screen is the policy. So as I said, the class maps or control classes are have automatically been configured. We'll take a look at them, and the main part, which is also in my new blog post, is the policy map. So this is what you're looking at on screen, and I've broke it down so that we can better understand what all this configuration is on the left and what it's doing. So the configuration is on the left and the explanation is on the right. So we'll quickly go through these. I don't want to spend too much time on it because I want to get into the lab so you can see what's actually going on. So we've got one policy here. So policy map type control subscriber policy data. So this essentially creates a policy called policy data. And then what it says is essentially when a MAC address is seen on a switch port, all classes are evaluated. So by classes, it means every class within the event. So what we have is event, class, and action. Within every event, there's a class and then there's an action. So as you can see on the top line, we've got an event, we've got a class, and this is an action. So it's saying what we'll do is we will use until it fails, we're going to use 802.1x or .1x, and it has a priority of 10, so it's going to be evaluated before MAC authentication bypass. And then moving further on, if we say in there, in the event that the authentication fails, we're going to match the first. So we're not matching all the classes, we're matching the first. So there's a few here. So 5 class .1x failed due until failure. So this probably ain't going to make sense to a lot of people until we look at the classes, but if we, it might make more sense actually if I get the classes up as well, so you can actually see what's in the classes. So let's log into my switch. Show run again. Okay, so there's a lot. So let's just find the one we're looking at, which was, if we go back to our presentation, it was class.1x failed. So what does class.1x failed say? Class.1x failed. So it's there we go. Class.1x failed is here. So this says basically match 802.1x. So match a session that's using 802.1x, and it's matching the result type, which is 802.1x authoritative. So this is saying if .1x fails, so we'll go back to this now. So if .1x fails, we're going to terminate .1x, so we're going to cancel .1x, and then 20, so that's the next one. So this is based on priority, so it's going to do that first, then 10, then 20. You can have numbers 1 to whatever, I can't remember what the number is. So it's going to first terminate .1x, and then it'll move on to trying to authenticate using MAB with a priority of 20. So that's what it's going to do. And then we've got a next one under the same event. So if authentication's failed, we've got a class called AAA server down unauth host. So let's have a look at what that is. So we've got unauth host here. So what this is saying is it's saying that if our AAA server times out, or if a connection to the AAA server times out, and the authorization status is unauthorized, then we're going to do the following. So let me just go back on this. So it's going to, first of all, it's going to clear the authenticated data host. I actually think sorry. It's gonna clear the if authentication's failed, it's gonna clear the host on the ports. Then it's gonna activate the following service template, which is called critical auth access. So if you remember, I said a service template is basically a policy within where you can specify a VLAN or access list, etc. So let's have a look at what critical auth access is. So we'll just have a look at the service templates. Let's show run. service templates. There we go. So it's going to activate service template critical auth access. So that's this one here. And I've also put a description in here for what this is. So this service template has basically got an access list. And that access list is called IPv4 critical ACL. So what this does is it's basically an access list that permits IP any. So in the event that the AAA server is down in a production environment, this could potentially stop users from being able to work or perform their daily activities. So what we need to do is we need a way to actually fail open. You don't really want to fail close, because then users will they won't be granted access to anything and they won't be able to carry out a task. So what this does, it'll activate this critical ACL that permits everything. So essentially a fail open. So if we just do show access list, so there is the access list, permit IP any. Okay, so going back to this, so it's going to activate that template, which is going to permit IP any, and then what it's going to do is it will also activate a template called default critical voice template. So let's have a look what that is. Just scroll up and we have a look for, there we go. So this is a template that's been created when we do the conversion from IBNS 1.0 to IBNS 2.0, and all this is got within is saying voice VLAN. So anything that needs to be put onto the voice VLAN will be put onto the voice VLAN. And then finally what we'll do is we will authorize the port, so the port will be permitted, and then we will pause re-authentication, because what we don't want to do is when a AAA server is down, we don't want to try and keep re-authenticating, because it's just going to be the same result until we know that the server is available again. So I'll just finish off these last three. There's actually another page, but hopefully you kind of get the gist. So I don't really want to touch on all of these. To actually see this breakdown, I've actually put the post on my website, networkwizkid.co.uk. It's also scrolling on the bottom there. You'll be able to read up more about this as well. So the next one is saying that if the AAA server is down but the host is authenticated, what we want to do is we don't want to clear the sessions like we did with the unauthenticated host. All we want to do is pause the re-authentication, and that's the reason I said the reason we pause the re-authentication is because of what I've just mentioned with trying to re-authenticate when a server's dead. And again, we will also authorize that port. Okay, so the next one, if the authentication fails, we've got a class called map failed. So within this class, it's just saying do map. So if MAC authentication bypass fails, we're going to terminate map. So we're going to stop trying to do MAC authentication bypass as an authentication method, and we're going to move on, and we're going to attempt to authenticate using .1x again, which is a priority 10. And likewise, if there's no response from .1x, this needs changing, by the way. I should have changed that. So if there's no response from .1x, we're going to terminate .1x, and instead of trying to authenticate using WebAuth or trying to do MAB again, we're going to restart the authentication in 60 seconds, so the cycle will start again. And then we also have some more failure scenarios that we've configured in classes. Yep, all the way down. And once you've essentially configured all your classes and you've created a policy around that, what we're going to do then is we apply the control policy to the interface. And then we've got some testing and verification commands that we can do after as well. So what we'll do is the actual policy itself isn't created. So we've seen the class maps that are created, and again I'll just show you the class maps, because if I were to create these now on this live session, it would take some time. So you can see all the class maps here, and that's a lot. So I didn't want to remove them and then start them again because it was pointless. We have some interfaces configured with basic configurations, but we have no policies assigned to them. So that's what we'll be doing once we've created the policy. We don't have a policy in place yet, so what we'll do is we'll actually configure the policy, and I've broke it down a little bit here so it makes sense more. And so we can just copy, because it's a lot of configuration, it actually makes sense, especially with the numbering, to configure it in a text editor first before actually applying the configuration onto your switches. So as you can see here, because it's easy to get mixed up, you've got 10 class, 20, 30, 40, 50, and so on if you want that. So and obviously then you've got events within. So when you start an event, or when you've got an event, then you start numbering again. So it can easily get complicated. So I think it's better to actually do it in a text editor first before actually applying this configuration. Let me just quickly see if we have any questions, and I will start to implement this on our switch. Naheem, to answer your question, which is what is your opinion on the best online resources for ICND1? It's been a long time since I did ICND1 or the CCENT, so I wouldn't be able to point you in any specific direction for content. However, I would recommend checking out Dewan's website, Lab Every Day. He's also on Twitter. He's got some links and videos to good resources which might help. So hopefully that will help you. Yes, Cash, the actual configuration is, or some of the configuration is available on my website, www.networkwizkid.co.uk. You'll be able to see that on that website and take that config from there to play with. Appreciate it, Ali. Again, thanks for watching, thanks for tuning in, man. It's much appreciated. Port and global configuration. So yeah, let me just, I think I quickly showed you that, didn't I? So if we, I think it was gig 1023. Yeah, so on this interface, this might vary. Just bear with me a minute. So the interface configuration will vary depending on your environment. This is my lab environment, so this is how I've got it configured. So this is the configuration I have on the interface at the moment without the policy applied yet, so we'll apply that policy once we've configured it. The global configuration, again, there's no set in stone configuration template. It's purely based on your environment and based on what you need to configure. So I can quickly show you just the amount of things that I've got configured in my global policy. Again, this is just a lab switch, so I don't mind showing you these configurations. But we've got a device sensor configuration, which is used for profiling with ICE. So we've got different filter lists set up and configured here based on TLVs. You got accounting attributes. Again, these are their basic .1x configuration that you'll require. The service templates, as we've already discussed, these can vary based on your requirements. Most, if you configure IBNS 1.0 and convert to IBNS 2.0, you will be able to, these will be converted. The only one that won't is this service template here that I've configured as well as this one here. So again, this is based on really whether you need or whether your environment has a critical VLAN. If not, then you can just apply the critical ACL to the VLAN that's already assigned to the port. And then what we've discussed already, we've got a bunch of class maps. Again, these are either converted or you can actually create these yourself, whatever your preference is. And then we just go on to the interface configuration, and then we've got radius server attributes configured, radius server, which is ICE, and the VLANs, etc. So again, it really depends on your environment. Configurations will vary. There's not kind of one set template as to what you should use. So I hope that makes sense. But let's get in anyway and start configuring this control policy. So we'll start off by actually creating the policy. So policy map type control. So as I mentioned before, it's a control policy, and we're going to call it policy data. And once the session started, we're going to try and use .1x first. So let's input that. So as I said, you've got an event, you've got a class, then you've got an action for that as well. That's how it works. So if we just exit out of that. And we'll just copy it. In fact, we'll copy it all so it's quicker, and then we can see the actual template. And I've actually slightly modified this just to kind of streamline it. But let's let's put all that in there. No, it's because the reason that's not done it because I exited out of the policy map. So let's go back into the policy map. Yep, and you just get a warning saying that if you make changes, it could impact everything else if it's already configured on a port. There we go. So which ones, such as car, match all, do until failure. So which ends that event. Ah yeah, so that one could have been taken out. I didn't actually need that one. So just to kind of scroll back up here, you can kind of see that you've got an event, you got a class, and then you got a bunch of actions, and you got class again and actions, and you got class and actions, class and actions, so all the way down. So hopefully that makes sense. So if we, I'm so glad that I didn't have to type all that out, because we would have been sat here for another 30 minutes. So what we'll do now is we'll just do a show run control, no, show run, no, show policy, do show run policy map. It's not showing. Let's just do it, just show run, and we'll take a look at the actual policy map now that we've configured it all. So this is how it looks. I'll just enter all that and we'll scroll back up. Violation match all, but we've not got all in that class. So we need to enter that. That's fine now. So here we have the policy map that we've created. So this is one policy map. You can create multiple policy maps and apply them to different interfaces. It all depends on your environment. So our policy map's called policy data. We've got an event, and we've got the class, and then we've got the action, all the way down, and you can see kind of how it puts it all together. Again, for those that are just tuning in or watching it back, this has already kind of been explained, and it's also available on my website. So if you want explanation to what all this means, then please do go on to my website. So that's the policy map, and before we apply it to the interface, for those that are familiar with IBNS 1.0 configuration, you would do a show authentication sessions, but when you change to IBNS 2.0, your configuration syntax changes from authentication to access sessions. So as you can see, I've done a do show access session here. I've got both of my devices as we have in the lab. So we've got the phone and the user device configured, and you see there that they're showing as unauthenticated at the moment. And let's have a look why. So if we have a look at this interface, let's just do show run, do show run. We can see that we have access session closed, so this means it's in closed mode. So essentially these are not granted network access until they authenticate, and we've already seen that they're unauthenticated or unauthorized, so they aren't being given network access. So what we need to do to actually change, let's just have a look at 24 as well, which 22, which for the phone, or the other way around. Again, it's the same thing, that's why they're both unauthenticated. So what we'll do, session. So we need to actually get this to change from unauthenticated to authenticated. We have ICE as well that we can look at. So if we just go on to ICE, we'll be able to look at the live logs to see any authentication. We can see that authentication is not happening as of yet. ICE is already configured, by the way, so we're not. The purpose of this is not to actually look too much at ICE today. It's to look at the IBNS 2.0 config. But ICE is already configured, so we're all good in that department. We should be good once we apply the policy. So if we just go back to our presentation. So when we've created a policy and we actually want to apply that policy, the service policy, to an interface, this is the command that you need here at the bottom: service policy type control subscriber, and this interface then becomes a subscriber of that policy. So our policy is called policy data. So I'll just copy that there so I don't have to type it out. And then what we'll do is we'll apply it on, let me just see which in the phone plugged into. So 23 is the PC, so we'll apply it on 23 and we'll see if we can get the status to change. So we need to apply the service policy type. So do service type policy control, and it's a subscriber of, and we can see all the service policies, all the policy maps that we have. The ones AI are these are kind of auto-generated policy maps. The one that we've created is obviously called policy data, so we'll use that one. So that interface now, 23 wasn't it? We can see now that it's a subscriber of policy data. So if we do show access session, do show there we go. So we can see, in fact, have I done the other interface? Yeah, I probably have. But nevertheless, we can see now that the phone has authenticated using .1x, and it's in the voice domain, and we can see that it's authenticated, and we've also got a session ID that we can track on ICE. So there's a few more configurations we can use, a few more show configurations we can use on the switch, but let's quickly have a look at ICE and see what's happening there. Just get a drink. So if I refresh this now, we can see that our phone has authenticated, and it's authenticated using .1x, and I know that it's using certificate-based authentication. That's beyond the scope of what we're talking about today, so don't worry about it. But if we click on this, we can get all the session information. So we can see that she used its username, which is a DX650 IP phone. We can see the authentication and authorization policy that is hit within ICE, and based on hitting those two, it's being given this this authorization result. So we can see the endpoint ID, which is the MAC address. We can see the phones being profiled as a Cisco IP phone, DX650. We can see the audit session ID, so let's just have a look if that's the same. It looks like it. So AC, yep, 704F, which I missed out. So you can see, so you can actually track things like that just to see which authentication is for what. We can see that the authentication method is used .1x, and we can see that it's used ETLS, which is certificate-based authentication. We can also see the device, the network access device, which is the switch. We can see the switch IP address, and then you've got loads of other information here as well, using ETLS certificates. So it's as simple as that. And if we want to, for the next one, before we apply the policy, we will actually have a look at the policy that it matches. So we'll do debug pre all, and what we'll do is we'll go on to it was 2422 the interface. Yep, so we'll apply the policy data control policy to our PC interface now. Let me just make sure it's turned on. So we'll apply that now to, let me just get the command so I don't have to type it all out. We'll apply that now to this interface, and hopefully we should see what is happening in the background. And we'll take it off so we can see here already what's happening. So I think that might have finished. So we can see as soon as we applied that service policy to the interface, before we actually do this, in fact, let's just make sure it's been authenticated. So we'll do show access session. So now we can see that the PC is also authenticated using .1x, and it's being put in a data VLAN. So let's just have a quick look at ICE, and then we'll go back up to the debug output and we'll kind of take a look at that. So we can see that the endpoint has been profiled as an HP device. The identity is administrator, so it's an admin account, and again I know that this is using ETLS, so it's using certificate-based authentication. And again we get the same details really as we got from the last one, but now we can see right at the bottom, authentication succeed. If we fly back to our output, let's see if we got anything useful. So it started to execute the policy map straight away, policy data. And it's evaluating all the different classes. Oops. Scroll back up. Let me just do login synchronous. Right, let me scroll up. So let's go through all the classes. We can see nothing, policy map, policy data, cluster until failure, evaluate class map success. action authenticate using .1x priority 10. So yes, it did use .1x and it says that it's been a success. So if we look here, we're actually looking at this line here. So authenticate using .1x priority 10. Authentication match all. Yeah, that's fine. So we can see that the service template should secure returned a success. So this will based on, so where's this in here? So here, if the event, the authentication successful, then we're going to apply this policy, which is should secure. So that's what it's done there as well. So it's returned a success. And that's pretty much it. So let me just do and debug all. And if we go back to our presentation, test and verify. Just bear with me a second. Sorry, I'm just getting messages as well. Not ideal when you're doing lives. So now that we've done that and we've verified that our hosts have now authenticated successfully because of our policy that we've created, we can do a few testing and verification configurations. So I've listed a few here, so we'll do these now. So, oops, I'm not on it. Just bear with me a second. Sorry, I just had to answer a call really quick. So let's verify the actual configurations now. So we'll do show class map, and we'll do type control subscriber. And there's a few things that we can do in here. So let's just start by using all, and we don't get anything in there really. So if we do user defined, we can actually see all the executed hits, miss, and the number of times that the execution's been completed. So we can see that our AAA server's been down. We can see .1x has failed. It's been executed twice and it's been hit once. So you kind of get the gist of it. You know, there's quite a significant amount of information that we can get from that, which is quite good. You can also look at the names. So again, some of these, the AI ones, are generated automatically, but then we've got the ones that we've created as well. And if we click on, let's say for instance, .1x failed, you know, you can kind of narrow it down rather than looking at all of them, which is quite good. Oops. We can also use a brief. So you can see the policies that are defined or bound to a policy. So a class map bound to a policy rather. So we can see that all of these are, all the AI ones, or most of them shouldn't be, because we're not using them. So again, that's good to see if there's any class maps in a policy. We can also have a look at the service templates. So we can see, if we do a show service template, you can see the different service templates that you've got. There's not much else you can do apart from actually specify that one. So if you actually go into each service template, you can see the attributes, if you like. So we can see here that we're using one access group, IPv4 critical ACL name. And then, you know, these are the other things that you can specify, as we mentioned earlier. So VLAN, idle timeouts, quality of service, stuff like that. So that could be quite handy as well, in fact. We also have show access session, which you've already seen. So this gives us information about the authenticated sessions or unauthenticated sessions on the switch. You can also go into more detail with these by actually specifying the interface. So say for instance we specify this interface and we say details. Let's have a look here. So we can see once we go into the details, we can see the interface, MAC address. We can see the IP address, which could be quite handy as well for troubleshooting. We can see the username, again could be quite handy. We can see that the port's authorized in the voice domain. We can see that we are allowing multi-authentication on this port. What else can we see? See the session ID, which we've already pointed out on ICE, which could be quite handy. And we can see the current policy that's applied, so this could be really handy if you're troubleshooting or things aren't working out how they should be. You can see the actual policy that you've got assigned to the port. Then we can see obviously local policies, so the service templates that we have. So we pointed this out already. We've got the service template default link set policy should secure, and we can see server policies. So local policies are policies on the or from the switch, and we've got server policies which are from, in my case, Cisco ICE. So Cisco ICE has pushed down a dynamic access list called ACS-ACL IP permit all traffic. So I think this bit's actually added on because it's called IP permit all traffic, and the last bit's added on. So that's pushed down from that's a DACL or dynamic access controller. It's pushed down from ICE, and we can also see the method which is used. So using .1x and the authentication has succeeded. So if we do that as well for port 22, again we can see that a username administrator is connected and authorized in the data domain. We can see, we can't see the IPv4 address. Let me just see why. So I've just took that out, as you can see, and put it back up. And we should be able to, once it gets an IP address, if it gets one, let me just have a look on the machine. Just give it a quick restart because it has been on for some time unauthenticated. So we'll give that a second and see what happens. But just looking at the syslog output here, we can see that this is an ACL that's been pushed from ICE. Again, ACS, ACL. Don't know why I didn't say ICE, ACL. IP address hasn't been given, so I'll just give it a restart and we'll see if we can get that just to finish off, and then we'll see if we've got any more questions and then we can finish off. So I hope this session has been useful. Again, as I say, the more descriptive breakdown of the control policy and control classes are on my website, which is scrolling on the bottom of the screen. So do look out for that. If you want to understand a little bit more about that. But I hope you found this session useful today. So let's take a look. I don't know why it doesn't seem to be authenticating. Let's just go over to ICE. We can see that it's authenticating, and that's the actual device authenticating. Let me just have a look. We'll just sign into the device. Just signing into that device now, and we'll see if we can get a change of status, and we'll see if we can see that on ICE. So yeah, we can see that here. Let's go back to this switch. What's that? Just going to plug it back in. just going to check the settings on the PC quickly. Let me confirm the connectivity with Active Directory. So let's do a diagnostics on it and we'll see what's cracking. Yes, it seems to be up, which is good. Let's go back to the settings on the computer a moment. Picking it up. Doesn't seem to be picking that IP address up, so let me change the port. I'll plug it into the phone port. See what happens then, but it might be something to do on the Active Directory side. Do a show is not for that 23. So once you plug the phone in to the computer into the phone on the same port, what you'll get is you'll get two different outputs. So I've done a short interface, short access session for gig 1023. And first of all, we get the details for the phone, and then we get the details for the PC as well here. I'm a bit unsure why. Let me just connect to the Active Directory. I'm a bit unsure why that's not getting an IP address, but it might be because Active Directory services might not be running, which is fine. But I guess the main points that I wanted to show you, I have shown you in regards to IBNS 2.0. The configuration is available on my website, as I've mentioned. Also more detailed description of that and more links. You can also click on this video to find out more about IBNS 2.0. This presentation will be shared on my website. You will be able to find it on my website, so if you want to download that, then you can, or refer back to it. But I appreciate those that have stuck with me today, and I hope you found this session useful. I'll just quickly turn it over to see if there's any questions, and if not, we shall call it a day. Ali, thank you for tuning in. If you're not there no more, I appreciate that, and I'm glad you found it interesting and useful. So thanks for sticking with me. If there's no more questions, which I don't think there is, looking at the screen, I will end this stream. Again, thank you for those that have tuned in for the very first session of the knowledge transfer this year. There is more to come. If you've got any ideas or you would like me to present something, then please reach out to me either via email, Twitter, Instagram, YouTube, and come forward with your suggestions, and I'll do my best to put together a presentation so that we can deliver a knowledge transfer on this and get that information out to you. But until then, thank you for watching.